Everyone, welcome to today's video. Today's lesson is on translations. What is a translation? It's basically part of a transformation. It's how we move a graph around. In this case here, a translation is how we're going to move a graph either up, down versus left and right. We have some special variables that we're going to denote to tell you which direction we're moving, either up and down or whether we're moving left and right. In this first equation here, we have y equals f of, and f, by the way, is a function f of x minus h. That h value there within the brackets tells you that you're going to move your graph either left or right. On the other side of the equation, we have y minus k equals f of x. For this equation here, normally we don't really keep it in this format. We can definitely rewrite it so that you have y by itself. So I'm going to quickly rewrite this equation as y equals f of x plus k in this case, because I want to get y isolated by itself. What is h and k? As mentioned, k is going to move all things up and down, so k is always going to be after your function, whatever your function is. We're always going to move things up and down, and h is within your function, and that's going to shift things left or right, and that's going to always be right beside your x value there. To start off these ideas, the best thing to do is to graph a few examples. So we're going to graph three graphs. So the first graph here is what I'm going to call is my base equation. I'm going to compare everything to this first graph here. So my first graph, I'm going to do all in blue. It's going to be this y equals x squared graph. The next graph I'm going to do is this second one here in the middle. We got the y minus 2 equals x squared, which I will eventually rewrite. And of course, last but not least, we have this guy here on the very far end, y equals x squared minus 4. Let's graph this first one here. Y equals x squared, that's a quadratic equation. I know that I have coordinates at 0, 0, 1, 1, 2, 4. And because it's a quadratic, it's going to mirror each other. So at negative 1, 1, and at negative 2, we're all the way at positive 4. Right now, I'm going to try my best to connect my dots. It should be a parabola. It should end up being a U shape anyway, so here we go. Trying my best to connect my dots, and it's kind of going slowly. And there we go. There's the first half. And let's see if we can do a bit better on this side here. Almost. There we go. That's our second half. So that's our first equation. This is my y equals x squared graph, all in blue. So we're going to try to compare everything to this original graph in blue. So this one here, we got this y minus 2 equals x squared. I'm going to move this minus 2, this subtract 2, to the other side of the equal sign here. So I'm going to quickly rewrite this as y equals x squared. Instead of minus 2, we're going to go plus 2. So what does that mean? Plus 2 at the end of our function means I'm going to move every single dot I see up 2. So my original origin was at 0, 0. Now I'm going to be at 0, 2. This 1, 1 is now at 1. Up 2 would be at 1, 3. Mirror over here, 1, 3, 1, negative 1 and 3. Here we're at 2, 4. If I go up 2, we're at 6. 6 is off the grid, but I'm going to try my best because here's 4, 5, 6. 6 should be just slightly above off the grid here. I'm going to try my best to add it in. And it should look something like that. And again, trying my best to connect my dots in a parabolic fashion. So it's going to look more like a U and less like a V. And there we go. So we have the second one, arrowheads on the end of it, and I'm just going to write the equation for it off to the side here. So this was y equals x squared plus 2. For my last equation here, y equals x squared minus 4, well, if you just realize that, hey, after your function plus 2 moved things up 2, minus 4 is going to take my original graph and move everything down 4. So from my original blue, I'm going to move every dot here, every coordinate down 4. So I got 1, 2, 3, 4. That's going to be my first coordinate. Those ones are now in. And at 2, I'm at 1, 2, 3, 4. right on my x-axis there to finish this one off. And again, sketching as best as I can to make it a parabola. And there we go. Arrowheads on the end of that, and label my equation. Y equals x squared minus 4. So after we have all three graphs graphed, it says compare the original function y equals x squared at any point xy to the first equation here, and the first one we did in red, and the second one here that we did in black. So I'm going to just slightly split my page here real quick to do both comparisons, one on the left, one on the right. So on the left, we are comparing y equals x squared, and on the right, we're also comparing y equals x squared. And both times we're comparing it to, on the left here, we're comparing it to y equals x squared plus 2. And then on the right, we're going to compare it to y equals x squared minus 4. So what do we know? We know that if you had a function and it's the same function and you had to add after the equation, it's going to move every dot up or vertically up. This is what we call a vertical translation. Vertical translation. So we have a vertical translation. We're moving it up 2 units. So literally I write vertical translation by 2 units up. By 2 units. And I needed the direction there. So up is going to be my direction, 2 units up. Over here, we have the base equation x squared, and we're comparing it to x squared minus 4. So clearly we're going minus 4, so that's down 4. So again, that's a vertical translation. So I'm going to write this down, vertical translation. By 4 units down. Eventually, you will get speedier at writing down these sentences. We'll probably short form it here eventually, just so that you don't have to write it out in full. But for now, this is going to be my first example, and we have all three done. In the next example, what do we have? We have a graph, y equals absolute value of x, and we're going to compare it to the next three. So we have absolute value of x minus 3 and absolute value of x plus 2. So again, I'm going to graph all three, and I will try my best to color code things. So the original here should have been in blue. Let's do that in blue. The next one, of course, we'll do in red, and finally we'll do the last one in black just to keep the same color pattern. So in blue here, we have absolute values, so that means at 0, you're at 0. At 1, the value there is going to be 1. At 2 is going to be 2, and so on and so on. At -1, the y value is going to be positive 1, and at -2 for an x value, y value is going to be positive 2. And there we go, we have a nice little V. I'm going to use a line to connect my dots here as best as I can. There we go, there's the first one. And there we go, there's the second one, perfect, done. Arrowheads on the end of it, perfect, because we still needed arrowheads because it's going on forever. This time here we have y equals x minus 3. So we're just going to pick a few values to see what happens to our graph. So let's pick a value for x. Let's start off with 0. Let's see what happens. If you picked if you picked x equals 0, y is going to be what? Well, you have 0 minus 3, which is -3. Absolute value of -3 is at positive 3. So at x equals 0, y is going to be at positive 3. So let's pick 1, let's say x equals 1. So if x equals 1 here, what's our y value? Well, we got 1 minus 3, which is -2. At absolute value of -2 is positive 2. So I'm just going to go and put a dot here at 1, 2. And I guarantee you it's going to continue this pattern. If it's going down, it's going to continue this pattern right until we get here, which is x equals 3. Well, what's 3 minus 3? That's 0. So at x equals 3, it's going to be at 0 for our y value, so we're good there. Because this is an absolute value, let's check out 4 here. 4 minus 3 is 1, so we have a y value of 1. And x at 5. 5 minus 3 is 2, so I'm going to put a dot right there at 2. Perfect, we have plenty of dots. We're going to connect our dots here and build our absolute value graph. And notice that I am going off the grid here. I go as far as I can, arrowheads on the end of it, just so that we finish that off. The last one here. So again, I have y equals x plus 2. I'm going to start off at 0. If I had 0 here, what would we get? Well, 0 plus 2 is just going to be positive 2. So I'm going to put a dot right here at positive 2. Let's go 1. So 1 plus 2 is going to be 3. So at x equals 1, we're at 3. So I know that based on this pattern, it's probably going up. So if at negative 1, where are we? At negative 1 plus 2 is negative 1. Absolute value of that is going to be 1. Sorry, negative 1 plus 2 is positive 1 still. Negative 2 plus 2 is going to be 0. Negative 3 plus 2 is negative 1. There we go. We're going to have positive 1 if it's in absolute values. Negative 4 plus 2 is negative 2. Absolute value of that is positive 2. And negative 5 is going to get us to a positive 3 in absolute values. Again, I'm going to graph and connect my dots here. There we go, there's the first line, and that's going to finish it off. There we go. So we have 3 graphs, one in blue, one in red, one in black. Again, we want to compare the original to this new function, more or less. So again, I'm going to split my page right in half and write down my comparison. So my comparison, I'm comparing everything to y equals absolute value of x. So y equals absolute value of x. Let's do compare on this side, y equals absolute value of x minus 3. And on this other side, y equals absolute value of x plus 2. So what do we notice? We notice that if there was a value, if there was a number beside x, and it's still within brackets, still within the function there, it does not move our graph up and down, but in fact it moves our graph left and right. Because we're moving left and right, that's a horizontal translation. And we just got to figure out, well, by how much. Horizontal translation by, or we can say horizontal translation and how many units we're going to go. 3 units. And which way did we go? Did we go left or right in this case? So in blue, to get to the red, we went 3 units to the right. Over here, we have a horizontal, and I'm just going to speed up my writing real quick. HT stands for horizontal translation. Horizontal translation, we moved it plus 2, but in fact, from the blue to the black, we moved it 2 to the left. So horizontal translation, 2 units left. All right, so what do we need to know about horizontal translation? So I put a star on this one. For all horizontal translations, so for y equals f of x minus h, there we go. For all horizontal translations, whatever this number here is on the inside, it's the opposite of what actually happened. So if in this case, what I mean is I had x minus 3. Usually most people think minus 3, I'm going 3 to the left, but it's going to be the exact opposite. In fact, we went 3 units to the right. Over here, we had x plus 2. Notice that that does not match up to this equation here. You do need the same thing. So in this case here, this one would have looked something like y equals f of x minus negative 2. You needed a double negative there. So if I had a negative 2, that means I'm now moving 2 units to the left. Or if you saw this positive 2 here, that means it's already been cleaned up. And think the opposite, and we're moving left, not right. In the next set of examples, what do we have here? So we have example 4, given the function, so we have a radical function this time. Describe the translation that's been applied to this equation here. Well, the very first thing I'm going to do is rewrite my equation, okay? That's always what I want to do. And again, I'm just going to quickly note at the top of our page here, what's our equation that we normally want to use? We want to use y equals f bracket x minus h close bracket plus k. And again, h is going to move things left, right. K is going to move things up and down. K has to be on the outside of your function. H has to be on the inside of your function next to x, always, always. So here's our equation. We got y plus 2 equals square root of x minus 3. I'm going to quickly rewrite that first off. So we got y equals square root of x minus 3. And that 2, originally positive 2 on the left, I'm going to move that to the right. So it's going to be, minus 2. Sorry, not positive 2, minus 2. So there we go. That's my first step. I rewrote the equation. So because I rewrote the equation, what do we have? We have that 3 is h, and this minus 2 is k. And again, k is I'm gonna take this whole thing here with the minus, and that's all k. With h, I'm gonna take just the number because it's x minus, and that matches up to our original equation. So we have an h and a k, so that means we definitely have a horizontal. Let's start off with a horizontal translation, meaning we moved it left and right. Which way? We're moving it horizontal translation 3 units. And the question is, which way are we going, left or right? Well, if it's x minus 3, think of the opposite, minus 3, meaning we went to the right, not to the left. So 3 units right. Here, this minus 2 is a vertical translation, so I'm going to write VT for vertical translation. How many units are we moving? We're moving 2 units. And if it's a negative, guess which way we're going? Are we going up or down? Well, if it's a negative, we're going to go 2 units down. If you really want, you could graph this equation out just to visualize. It does make it look a bit nicer, but here's a quick sketch, just an FYI, in case you ever need it. So again, here's my original radical. And from this radical, my new one is going to be moving everything 3 units to the right, 2 units down. So 3 to the right, 2 down would start somewhere around here. I'm going to do that in red actually, somewhere down here. And it's going to look something like this guy here. And again, if you graph this out on your graphing calculator, you'll see it and it'll make a bit more sense. I like to visualize it, so I would strongly suggest for you to use your graphing calculator. In the next example here, we have given the following coordinates for the original function in A. Locate the corresponding image coordinates in the transformed function. So basically, find the answer. So this is your original. You're going to find the image, aka what happens after the transformation. We're going to try to find all the things that happen after the transformation. So how do we do that? So going back to the top here, if this is my original equation, here's what I need to know about it. From my original equation, I could do something like this. I can pull out, sorry, that shouldn't have happened there. I can pull out my h's and k's to help me figure out where things are going to go. I'm just slightly moving this out of the way just so that we have space to work. I apologize. So what I mean is pull out our h and k values. We're going to do something called mapping. Mapping is a very, very good skill set to kind of just draw out information and see what happens to it. So all your original coordinates are always x, comma, y. Those are always your original. What happens to x, comma, y is the following. We want to get all the horizontals with x, so that means our x value, we're going to add on any sort of h value that we had in the equation. For my y values, we're going to add on any k's that we had in the equation. That's going to change up my coordinates. And I think I could try to fit it all there. Yes, I can. So from our original coordinates x, y, we're going to do the following. All h's, h meaning horizontal, is going to affect only your x values. All k's, which is your vertical, is only going to affect all your y values. Okay, so let's take a look here. So in part B, if we were given the original 0, 0 as a coordinate and we had to move things right 3 and 2 down, how would that affect our variables basically? How would that affect x's and y's? So off to the side here, I'm just going to write a quick note. Our original was x comma y. Our image is going to be what? Well, our image is going to be x, and what's happening to x? Are we moving it left to right? We're moving it to the right, so that means it's going to be x plus 3 because we moved it to the right. Vertical translation 2 units down, so that's going to be y minus 2 to every single y value, because that makes us move everything down 2, and this plus 3 is going to make all the x values shift over positive 3. So here we go. If you had 0, 0, I'm going to go 0 plus 3 and 0 minus 2. What does that get us? So let's do some math off to the side here. So I got 0 plus 3 for my x's, 0 plus 2 there for my y's, or minus 2, sorry. 0 minus 2. And let's see what our new coordinate's going to be once we clean this up. Well, our new coordinate's going to be 3 comma negative 2. Done. That's the first one. That's pretty much it. For the second one, we're going to follow the exact same process. So if we had 1, 1, I'm going to go 1 plus 3 here and 1 minus 2 here. And let's clean up our coordinates to see what we get. Well, 1 plus 3 is going to get me to 4. And 1 minus 2, of course, gets me to negative 1. So that's going to be my new image coordinates. Over here, we got 4, 2. So what's happening to 4, 2? So we're going to go 4 plus 3, comma, our original y value is 2. We're going to subtract 2 from it. So what do we get? We get, well, 4 and 3 make 7, comma, 0. It's going to be my new image coordinate. Again, mapping is a very, very good skill set that you should be trying to practice as much as you can. It does really help with pulling information out of an equation and plugging it into your new coordinates. It might even help you with graphing. In the next example here, two graphs are already given to us. Basically, all we're trying to do is, hey, if you had f of x, try to get it to become g of x. So how do we do that? The best way that we're going to do this is if we compare something that's the same on both. Well, in this case here, I want to compare the vertex of both because that's something that I know both graphs have. So there's a vertex there, and the vertex for the other one is right there. It's the same coordinate, or it's not the same coordinate, it's the same position on the graph, different coordinate value. On this one here, if we had 0, 0, as our origin and on our original, and we're trying to get to this one here, and this looks to be at negative 3, negative 2 for a vertex here, comparing that to 0, 0. How did we get there? Well, we're definitely going to need to move our graph 3 to the left, so that's a horizontal translation, 3 units left. But we also need to move our graph 2 down, and then 3 to the left, or 3 to the left, and then 2 down. It doesn't matter what you do or in what order you do it in, as long as you're going 3 left, 2 down to get to this vertex here. So that's a vertical translation, 2 units down. To plug this into our equation, here we go. Let's write down the skeleton. So we got y equals f of x minus h plus k. That's my skeleton equation. I'm going to fill it all in now. So I have y equals f of x. So all of that there, none of that changes. I have a subtraction sign here. What's my horizontal translation? Well, my horizontal translation is 3 left. So let's write down 3 left. 3 left should be minus 3, because that's what 3 left truly is. And then 2 units down, so 2 down would be minus 2 for a k value, so minus 2. Here, though, I see a double negative. I'm going to try my best to clean up. Anytime I see that in our equation, I'm going to clean that up. So we have y equals f of x Two negatives make a positive, so I'm going to change color there, positive 3 minus 2. Oh, and I missed coloring. Should keep that the same color. Okay, so here's what we have. So if I had an equation and it looks something like this is x plus 3, meaning that positive, if it's inside the bracket, think the opposite. Instead of going 3 to the right, it should be 3 to the left, and that matches up to our horizontal translation, 3 units left. Minus 2 after that function means we moved everything 2 down. Here below this example is a quick note on mapping, and it gives you an example of mapping. We just did a question on mapping previously, so we're good here. We're going to jump right to example 6 here and work on some more mapping questions. So what are we doing here? Basically, for example 6 here, it says we're going to be given this point, negative 3, 6. It's on some sort of graph. Graph of x, really, this should be graph of f of x, really. So there's a typo missing. Graph of f of x, whatever that function is. State the coordinate of the image at this point under the following transformation. So here's our original, here's our transformation. What's our final answer going to be? So again, very, very similar to the previous questions that we've been doing. So I'm going to start off with my 3, 6. That's my original. What's happening to 3, 6 there? Well, x looks like nothing's happening, so it's going to stay at negative 3. Y we have is 6 value, 6. And what are we doing to it? We're going to subtract 6, so minus 6 from it. What's our new image? So we have minus 3, and 6 minus 6, of course, is going to get us to 0. So my new coordinate after this first transformation is negative 3, 0. In this middle example here, again, we're going to start off with our negative 3, 6. And what's happening in this case here? Well, that negative 3, we're going to add 5 to it. So let's go plus 5. And that y value of 6 is still y. So nothing's happening there. So I'm just going to write down 6. So let's clean this up. So I got negative 3 plus 5. What is negative 3 and 5? That makes 2. That 6, nothing happened to it. So my new coordinate is going to be 2, 6. On this very last equation here, we have negative 3 and 6 to start again. And we're doing a double transformation in this case here. So what's happening? We have negative 3, and we're going to subtract 2 from it. And you have your 6, and in this case, we're going to add 8 to it. So again, let's clean up our equation. Let's see what happens. Well, negative 3 and negative 2, that's going to make negative 5. And 6 and 8 make 14. So my new coordinate, negative 5, 14. Don't forget, throw that in brackets just to finish that off because it is an ordered pair. So that's example 6. Jumping right to example 7, it says write the equation of the following. Write the equation of the image. So again, we're just writing the equation after the fact. So what's our skeleton equation that we always want to try to fill in? Our skeleton equation is going to be y equals f of x minus h plus k. So the very first thing to do in these questions here is figure out what's my h, what's my k value? Do I have an h and k in these questions? So here's my function. I got y equals x squared. That's my original function. It's going to be a parabolic function. After a horizontal translation, 3 units to the right. Well, it's telling you ht, horizontal translation, 3 units right. 3 units right is the h value. We're only affecting h. H is going to be positive 3 because we're moving it 3 to the right. So I'm going to quickly rewrite an equation. So instead of saying y equals x squared, because that's my original, I'm going to go y equals bracket x squared on the outside because that's my original x squared. If I needed it to move 3 to the right, my original equation should have had a minus sign and that 3 right there because it's going to be the exact opposite of what I see. So x minus 3 inside the bracket here is going to move things to the right by 3. So again, anything horizontal translation, you always need to think the opposite. Once you pull it out of the brackets, it's going to be positive 3. You move things 3 to the right. In this next example, here's our function. We are vertically translating it 2 units up. So vertical translation only affects our k value. 2 units up, meaning it's going to be plus 2. So here's my equation. I have y equals 10x. So that's my function. And to move this equation 2 up, I'm going to just go plus 2 at the end of it. So I'm going to go plus 2 right after everything there, not beside the x there, but after the whole function, which is 10 exponent x. So after that function, plus 2. This last example here, what do we have? So we have a radical, and what are we doing? We got two things, it looks like. So we have horizontal translation, 4 units left. So horizontal translation only affects h, 4 units left, meaning we have h equals minus 4. Vertical translation, we have vertical translation 3 units down, so that's k. If we're going down, that means it's minus 3. So let's fill in our equation here. So our equation is y equals no longer f of x, because we know our function. We know our function is the radical. So here we go. Let's fit in a radical symbol. Y equals square roots. X is right here. If I need to move things 4 to the left, it's going to be minus negative 4. 4 to the left. And then we have our minus 3 after the radical symbol. So that minus 3 is just on the outside. Here I see double negatives. I got to clean that up. So this is going to be y equals x. And 2 negatives make a positive, of course, so that's plus 4. Radical symbol, minus 3 tacked to the end of that equation. Reminder that that radical stops right after the 4 there. There is a subtraction sign there. So again, what do we know? If it's a positive 4 inside the bracket next to x here, it's the opposite sign when you pull it out, really. So if it's positive 4, it's 4 units left. And the vertical translation of 3 down, so we have a minus 3 at the end of that equation, and that kind of finishes off this question. The last example for today here, we have a radical symbol. What vertical translation would be applied to this function so that the translation image passes through 16.7? So basically, what are we doing here? We're giving you the answer. That's what it is. Image is we gave you the answer. So we got to go through a few different steps. So basically, we're doing the following. We have x comma y. That's my origin or original. We are trying to find that. We're doing x plus h, and then y plus k. And whatever that is cleaned up is going to get us our image. And I'm going to put image in quotations because it's really an ordered pair, whatever that cleaned up is. And here ORI is part of our original, okay? So I gave you the answer, so let's work backwards. So if our answer is 16 comma 7, so that means something happened to this equation here. Well, let's talk about this original equation. If you had the 16 plugged into this equation, what's our original y value? So originally, if x was 16, my original y value square root of 16 should have been 4. So this is my original. So I went from 16.4, I did something to it, and I'm going to leave a big gap there, and I got to an image. I got to an image value of 16 comma 7. So it looks like my x's did not change, so 16 should stay right here. Nothing to it. I'm not doing anything to it. I have my original 4 here. I need to do something to this 4 to get to 7. Really, it's going to be plus 3. This plus 3 is going to be this k value. So I got 4 plus 3 equals 7. So that means I have a horizontal translation up 3 units. And that's basically what I'm going to write down. So what vertical translation? So we have a vertical translation 3 units up to go from 16.4 to get up to 16.7, our final answer. Here is the same question here. We got 17.4 as our final answer. We got to find what happened to the original. Again, our original should have been 16.4. If you square root 16, it should have been 4. So something clearly happened to our x value there. So let's take a look. So if our original was 16 comma 4, we did something to get up to 17, 4. So clearly here, our y values did not change at all. It's still going to be 4 there, so I'm going to leave y as 4. Here, my original was 16. I got to do something to get to 17. Really, it's going to be plus 1. So 16 plus 1 is 17. That 4 is still there. So this plus 1 is a horizontal translation because that only affected our x values. Horizontal translation, 1 unit. Well, plus 1, which way are we going to move our graph? 1 unit to the right. So in terms of mapping, whatever that number is, it's going to correspond to the correct direction. In terms of our equation, whatever's in the equation for horizontal translation, remember, it's always going to be the exact opposite when we take it out. To finalize our notes here, this is the end of our notes. We have the following. So we have if your function y minus k equals f of x, or y equals f of x plus k. This, by the way, the second one here is the number one that we always use. That's the one that we always use. We have a vertical translation of what happens. Well, if you have k, and let's take a look at just the second equation here. If your k value is greater than 0, so that's going to be plus 1, plus 2, plus 3, the translation is going to move your graph up. Whereas if k was less than 0, so if you had plus -1, plus -2, plus -3, really you don't need that plus sign anymore. If it was just -2, -3, -4, -5, that minus sign is going to tell us that we're going to move things down. On the bottom here, we have y equals f of x minus h, so we're talking about horizontal translations here. So in this equation here, horizontal translation, if h in this equation was greater than 0, so if you had x minus a number bigger than 0, so you're thinking x minus h there, h alone, don't worry about that minus sign, so it's x minus positive 1, x minus positive 2, x minus positive 3. So my example here, i.e. off to the side, is going to be f of x minus, and my h value here greater than 0 would, let's pick 2. Because I'm only looking at h. If it's bigger than 2, really the translation is we are moving things to the right. And in this one here, if h is less than 0, so that means if you had f of x minus, and pick a number for h less than 0, so let's pick, I don't know, -3, because that is definitely less than 0. Again, two negatives here we know will clean up. So that's f of x plus 3. Okay, so if it's plus 3 here, that means the translation is we moved it to the left. So again, it all depends on this h value. So if your h value was greater than 0, so first off, if it's greater than 0, we're going to pick a number x minus, pick a number greater than 0. Then if it's less than 0, it's going to have this double negative action where we clean up the equation and it has to move it left. Mapping wise, here we go. Mapping xy, if we're moving things up and down, it's only going to affect the y values. K is going to only affect y. And if we're moving things left and right, it's only going to affect our x values. And in mapping terms here, if h was greater than 0, we're going to move things to the right. And this is for mapping only. And if h was less than 0, we're going to move things to the left. Okay, and that kind of works out there. That's the end of our lesson. If you have any questions, please let me know.